Welcome back. Today we are going to talk about the Zyber Blanc BM1373 miner. This is produced by a company called TCH, and TCH touts that this is the very first single chip BM1373 miner on the market. TCH has been in the small miner market for the last couple of years. I think there's a lot of controversy back and forth with open source, closed source. They use some things in open source design. They do some things in a closed source design. I believe this is a closed source design model. They have created their own firmware. I don't know if it's based on XOS. I don't know which was open source. I don't know if it's completely built in-house. I'm not going to speculate. I'm not sure. But we're going to review the build quality, the components that make this up, the overall design, and what our impressions of it are. So let's start with the breakdown. So what I've done is I've changed my little microscope lens out for you so we get a little bit better view. You know, overall first impressions, just looking at it, it looks cool. It's heavy. The base is made out of what feels like a cast aluminum. It appears to be powder coated. It's got a little bit of a silk screen for their logo. There's an insert that's got kind of a clear pass-through for the lighting. The board's got some LEDs on it. This appears to be 3D printed based on the layer lines I'm seeing. And then a clear acrylic top. When it's plugged in, we'll go ahead and plug it in so you can see it. It lights up. There's 3 different colors. There's the red, a yellow, and a purple. It is relatively loud and when the fans are fully ramped. So I wouldn't think this is something you're going to put on your work desk. The lights actually have mean something. They're different statuses. We're going to cover that in a minute. But before we get into that, let's do a full breakdown. So we've got 2 40mm fans. We have a barrel jack, similar to what we've seen on previous BitX products. We have a USB-C, I'm assuming for flashing or for direct log recovery. And we have a boot and a reset. So we'll go ahead and pull this board out. I'm going to take out the 4 screws, or the 3. Unfortunately, there's 4 screw holes, but ours only came with 3 screws in it. Take our screws out. We've got 2 JST fan headers, similar to what you see on Raspberry Pi 5. I don't know how they're wired in relation to that. I know one of the issues on the BitX was that most of these fans with JST headers on them are designed around the wiring for Raspberry Pi, which is different than the wiring that we see on a BitX. So I'm not sure. So we're going to go ahead and slide these fans up and out of here. And we'll grab the main board. We've got some thermal pads. Some stayed on the back of the board. Some stayed in the case. Looks like they're using the base here for some thermal transfer. The cooling is a passive cooling design, so it's got an intake fan on the left and an exhaust fan on the right. That's going to be important. We talk about that in a few minutes. We'll go ahead and pull the main heat sink off. It is a 2-screw design. They utilize 4 thermal pads for probably 2 reasons. One, to pass some of the heat from the board up through to pull heat out, and probably a little bit for stability in the heatsink. And we've got our BM1373 chip. So let's get that cleaned off real quick. This is actually shipped with a blue thermal paste. We have taken this apart more than once, obviously in preparation for this video. So we'll get this cleaned up real quick. We replaced their blue thermal paste with a Arctic MX7. So we have a BM1373CC chip. And like I always do, I'm looking for cracks because every single 1373 miner I've touched so far has had cracked ASICs. This one does not appear to have any cracks in it. That's good. All right, so let's get a breakdown of what we got on this board. Here, we'll yank these heat sinks off real quick. Okay, we've got a series of LEDs on both sides. Obviously, that's for the lighting effect. We get two JST style fan headers, a boot and a reset. We've got our R22 coil, and we've got a TPS. It appears to be the same TPS that we use, that we see on the BitX devices. A TPS, here we'll go a little bit closer. 546D24A. We've got some supporting caps and resistors, likely the same setup that we see on the BitX devices. Let's go to the back side of the board. It looks like we've got a D1 diode. It appears to be a TVS diode, not 100% sure, but I would venture to think this is a TVS diode. What we see on like the nerd devices, this protects from over voltage. We see three, it looks like LDOs. It looks like we've got an intentionally bridged LDO there, likely the 3V3. So I'm going to assume that this is a 3V3, like a 1.2 and a 0.8 for our various output voltages required, but I'm not positive on that. We see the same TX chip that we see on BitX's or on nerd devices. Looks like we've got, I believe that's an ESP module. Let's clean that off. Yeah, this is an ESP32 module. So what they've done here is instead of using the typical ESP32 assembly, they've got a WinBond firmware chip. So this is where all of our firmware is stored. We've got a clock chip to support this circuit in the ESP32, and looks like they've integrated the antenna into the main board. Supporting caps, resistors. We've got our fan control chip here with our two resistors. That's what we typically see. A series of caps on the main power rail. Yeah, pretty typical supporting components, with the exception that we haven't seen before in this market space is that instead of using a complete ESP32 assembly, they've broken it down into some of its parts. Very similar to what we see. This is a LilyGo display. And here we got a WinBond chip, our ESP32 module, and our crystal. So instead of having this complete assembly or what we see in an ESP32 module like on a BitX, they've integrated it into the board and used the components directly. That's what we see here. So relatively thin board and light. Doesn't appear to have a ton of copper in it. I would have thought that they would have got a little bit thicker on the copper. This is the version 1.1.1. And again, I'm a little surprised to see an intentional jumping and removal of these two resistors. However, this is probably the result of a rush to market type situation to get this out as quick as they can, try and capitalize on the market. It's unfortunate, but you know, sometimes companies do that. So that's really the breakdown of what we got here. So I would say repairability, absolutely, with the exception of probably some of the components that they're using around here in this ESP32. Some of these, and if they've made a change to any of these supporting capacitors, it would be difficult to understand or to isolate what exactly some of these may be. Again, I don't know. I don't believe that this is open source at all. So, but you know, I can get an ESP32. I can get a WinBond chip. I can get the communications chip. I can get many of these chips, the fan controller chip, the coil, the TPS. Those are pretty obvious. So repairable? Yeah, very likely. It's like I said before, though, it's relatively thin and light, so it'd be interesting to see how it does controlling heat. And given a pass-through design, I would imagine that they're probably and the sound it makes, it's probably somewhat of a struggle, but we're going to investigate that a little bit more. So this is what's inside the Zyber Blanc. Now, we just today got an email from them saying that they had an update kit or an upgrade kit for this available and asked if we were interested. I don't know what's in that kit. We'll cover that in a second video where we will request it. We just I don't know what's in it yet. So nothing on their website talks about what's in this quote unquote upgrade kit. So we're gonna have to find out. All right, let's put it back together and take a look. Again, we've got some 1 mil, these appear to be 1 millimeter thermal pads. Let's clean up this thermal paste. As I said before, this shipped with blue thermal paste on it. Not sure what it was, but whenever we take it off, obviously we replace it. So clean this excess off here. So pass-through cooling design, and with a loose lid, I'm really curious as to how that's going to perform. Now we've done some preliminary testing on it. I will say that the fans are loud, as I've mentioned before. Perfect amount of thermal paste. This is a 2-screw design on the mounting for the heatsink, so we need to be cautious as to how we mount this, just to make sure we've got good equal pressure along both sides and we don't over tighten the screws. And we can see here it's a little tighter here than it is on this side. So what I need to do is back this one off just a little bit. Tighten this one up. We want to try and get as balanced as we can so we have good equal pressure. That looks better. Yeah, it looks better. Okay. So pass-through cooling design, we'll remount these heat sinks. So it looks like they're cooling the ESP32 chip through the board on the back side with this heat sink. And they're cooling the TPS with this heat sink. All these fins pointing in the same direction because airflow passes through intake and out. Now I find it easier if we put these fans kind of back on before we drop this back in. The fans are different, which I find interesting. I don't know, this one doesn't have any information on it. This fan here, which is our intake fan, is this one here. Both 5 volt, whole miner's 5 volt. So we'll get this reassembled. This tiny fan header is going to be a pain sometimes. I imagine they use these headers because of the size. All right, we'll drop this fan in here. We gotta be careful on the orientation of the wiring, and I probably have it wrong, but I wanna make sure that this fan doesn't stick up at all because that other cover just sits on top. They had this bundled around with a wire tie, like from Bread, the coated metal wire tie. Actually, you know what, before I do that, I'm gonna drop in these screws. And then this, I like to tuck here. I've seen in images of their website where they've tucked it in to the actual heatsink itself, but I really don't want to lose any thermal capacity on the heatsink if I can avoid it. And we'll drop the other fan in like so. does that sit? Okay, that's sitting flat. Okay, so now I'll go ahead and power it up using their provided power supply, which is a universal. So the base, I'll show you that in a second, the base of the plug actually changes, it's interchangeable. So that you can put like US, Europe, APAC, that style of plug adapter, so it's a switching power supply. Okay, you guys can't screen see my monitor, but I've got it plugged in. We've got a yellow light. Now it should be hashing. So it started hashing and it fell off. Now we've seen this behavior, which we find pretty interesting. So it says it's hashing. Temperature's at 40, fan's at 30%. I've got an auto mode on the fan. We've seen some strange behavior with this device where it will start to hash and fall off. I'll go back to the main cam here. It'll start to hash and then it falls off. The voltage right now, it's at 17 watts and 4.83 volts. It's flashing yellow and the status says it's hashing. I can see all the registers. I see a peak from the hash rate coming up and then it fell off. And let's see what it does. Our temperature is climbing, our wattage is climbing, so in all intents and purposes, the ASIC is getting the work. We'll let it go through and sit here. So we've seen, I mentioned earlier, we've seen some strange behavior with the hashing on this device. And it's been like that since the day we got it, which we found pretty interesting. And I don't know if it's firmware related or hardware related, not really sure. But the status says it's hashing and we have no hash rate. And that was one of the things that we noticed pretty quickly, that even when you first connect it, so let me power cycle it real quick. I'm gonna power cycle this. And we'll refresh the dashboard. So our lights are red. Status is immediately hashing. It never has an initialization status. The status indicator on here doesn't really tell us much. The board showing yellow, which means it's, let's see what TCH says that these mean. Here is the description from Tiny Chip Hub. LED colors: red, starting hardware detection, switching operation mode; yellow, connecting to Wi-Fi or searching for the network; and purple, no more operation, connecting to a mining pool. So we're in yellow. Says it's hashing, status is hashing, that never changes. I would think that it'd be good to align that status with the light colors, but that doesn't appear to be the case. So very interesting behavior, and I don't know if it's just our device or if this is pretty normal across their spectrum of product, or normal across all the ones that are out there. I'm not sure. 18.3 watts. It sees all the domains. The input voltage is at 4.82, so it's definitely loaded, but no hashing yet. Still flashing yellow. So we saw this behavior earlier. I've kind of been testing this on and off, and it will appear to just go purple and start hashing. No problem. I don't know if it's struggling to connect to the network. It says connected, minus 76 dBm. I don't have any other issues with network connectivity. You see the other miners I have running here. I don't have an overabundance of miners running. I've only got the 2 running right now. So my network isn't saturated. So I'm not really sure what exactly is going on with it. It just, the status seems to be a bit clunky. And again, we've seen this behavior since we got it. I have updated this to the latest version as of the time of this recording, which is version 1.1.6. Not really sure. We'll let it continue to sit here and think and see if it decides it wants to start hashing again. Like I said, our input voltage is at 4.82, so it's a little on the low side, in my opinion. One of the things that I want to point out here, I'm gonna share this. That I can't say I'm a huge fan of. You see we're still yellow. Is that, again, I've talked about this being a pass-through cooling design. So we have an intake on this side. We have an output on this side. If this comes off, gets knocked off, falls off, gets bumped, you lose the passive cooling capability. We've tested this and we start to see, obviously, ASIC temperatures climb. The device has a problem controlling it. So it would have been nice to see this be more permanently affixed or at least affixed in a way that could be taken off intentionally and not necessarily bumped. Looks really nice. Functionally, you know, it probably leaves a lot to be desired. Again, you see we're still waiting for this thing to start deciding to hash. Not really sure why. I've gone rounds with this thing trying to figure it out. There's no rhyme or reason to it at all. It'll start to hash and then falls off, or it'll sit here like this, and after a couple of minutes, some time, it decides it'll start to hash. It's hit or miss. So temperatures are continuing to climb. The ASIC's getting voltage. Not really sure why. We'll give it a quick reboot real fast and see if it decides it wants to hash again. So you'll see the light indicator change. There's our red, our startup. Again, dashboard says hashing. Fans ramp. $18.7 watts, so it's initialized the ASIC. You can see the registers. We don't have overly high temperatures. VR temp's at 45C, ASIC's at 50. So we're hashing at 600 gigahash, 1772, 2305. All of our domains are registering. And you see our lights purple. It's kind of baffling. I'm not really sure why this is acting this way. Again, I don't know if this is a firmware related issue or hardware related issue, but now our hash rate's falling off. You see we're at yellow. So I don't know if it's picking up and dropping the network to the pool. I'm not really sure. I'm not really sure what's going on. Again, we've got a cast metal case, which could absolutely be impacting the ability to connect to the network. I have no idea. No idea. But again, I think if I was to criticize this product, I would say, one, this is probably the biggest issue I have. I have pets, you know. A quick tap, bump, right? It comes off. Cat's playing around with it. You know, girlfriend reaches to grab something. Now this thing isn't cooling. It looks good, but you got to be careful with it. It's a bit noisy. I don't know if you can pick it up in my microphone. And as you can see, it hashed. It still is not back on hashing. So probably need to have it close, real close to your Wi-Fi access point. Again, I don't have any problems with any of the other miners accessing the Wi-Fi. I have no idea. Not really sure exactly what's causing. I can test that more later directly under an access point and see if I see any improvement. But yeah, so back to that criticism. So again, this is probably my biggest concern here. I've seen in their newer designs that they've gone away from this, and they're using a fan on the top blowing down on it. It's in a standoff acrylic case like you see in their hex versions. So again, I think design looks really good. Execution probably a little on the poor side. The power plug is not tight in these. I mean, I just bumped it. It's off. I barely touch it. Here, I'll put the microscope back on. I mean, it is super easy to come in and out. And the voltage on these is low under load, which I'm not a big fan of. So I'm going to connect one of our standard BitX power supplies to it, 5 volt. And let's see what the voltage looks like then. The other thing that we noticed while this is starting up, we noticed during our testing, is this device has a real hard time maintaining a consistent fan RPM. And I believe what's happening here is with a thinner board, it is overshooting and undershooting the temperature that it's trying to target. And I don't know if they can work that out in firmware or if they need to do a design change to stabilize that, but it's kind of annoying when it's ramping up and down quite a bit. And because these are 40 millimeter high RPM fans, it's very noticeable. Without the additional thermal mass in the board, it's going to be difficult to target and hold a temperature. You're going to see high fluctuations when you don't have a really dense, thicker, higher copper level board. So voltage on this is plugged in now. We're at 5.43. It's at 8 watts. It's going through its startup sequence. Again, status just says hashing. So it's very interesting. Not really sure exactly what's going on with this device. It's very interesting. So I'll leave it plugged in and see if it starts to hash. But we wanted to provide our feedback on it, give you a full breakdown of what we see inside the board. It's what we believe its repairability level is, kind of the way they've designed it and built it. I think we see a little bit of a rush to market design here with what we saw with the jumping on the LDOs. So yeah, again, I think visually it looks really cool. I really like the aluminum base. I think it brings a nice design cue to the market. I just think it probably could have been a little bit better executed. So yeah, still at 8 watts, still trying to figure out what it wants to do. The other thing I want to point out, when you buy this device, if you buy this device, you're not going to be able to identify this device in the swarm. So you're going to have to follow their instructions on how to pick the device up on your local network. So you'll get it in, it'll broadcast to Wi-Fi, you'll configure it to your local network, but then you have no way to know what the local IP address is. So you either have to use the host name or you've got to do like an angry IP or go on TGH website and they give you another method to try and identify it on your local network. But you got to identify on the local network to get to the dashboard. So it's a bit clunky, in my opinion. It's going to be hard for first-time users. They're probably getting a lot of questions on how to access it. But yeah, so just keep in mind you will not be able to see it on your current swarm as of August 4, 2026. It does not get picked up on the swarm in XOS at all. So again, this thing doesn't want to hash now. It's so hit or miss. I'm not really sure exactly why, if it's firmware related or if it's a network strength issue. Not really sure. Well, whole time it just says status hashing. So confusing, if you ask me. On their dashboard, they could probably stand to make some changes and some corrections there. But anyways, that's our feedback. We'll see if I can get to the bottom of this and what the root cause of these problems are. Otherwise, it appears to be either firmware related or potentially hardware related. Not really sure, but it kind of decides to hash when it wants to hash and doesn't when it doesn't. But if anything changes and we figure out what's going on, we'll make sure we create another video and get you guys up to date. So just wanted to provide our feedback. Again, if you want to send any of your miners in for repair, ixtech.xyz, that's ixtech.xyz. Click the repair link at the top, fill out the form, pay $25, read the form, make sure that you have a piece of paper inside as the form states so that we can identify it when it shows up, because a lot of time return labels may not have your name and return address on it, especially if you go to a UPS store or something, give it to them and to have them ship it out. We're seeing a lot of labels come in with just that UPS store's information on the return, which doesn't help us identify who it belongs to. So make sure that you read the form really carefully before you send it in. Also, you need any accessories for your miners, please check us out, ixtech.xyz. Thanks for watching.